going with it. Rational functions, blah, blah, blah. If I said find the domain of this, you just have to remember, if you see a denominator, you can't have a denominator equal to 0. So your domain has to be excluding what makes the denominator equal to 0, which is sometimes pretty easy to tell, right? What can't x be in this problem? -10. X cannot be -10. Now we need to write that in domain notation, so you have two options. One option is set notation, right? So you say all x such that x cannot equal -10. The other option is interval notation, which would just mean we skip over -10. So we would say -infinity up to -10, union -10 to infinity. I don't care which one you do, but you have to, if you're doing set notation, you have to do little brackets. Don't just say x can equal -10. Right? Remember doing this? What about number 2? What can't x be? -2 and 6. What if that was multiplied out? You might actually have to factor the denominator. This one I worked out nice for you. Which means I kind of push interval notation because I feel like most colleges these days, in that basic math class that most people have to take that aren't going to be math majors, they teach interval notation. So I like to show it to you. But I definitely agree on a question like number 2. It's much easier to do this for your domain than it is to skip over both -2 and 6. That's a lot of intervals, right? Like you would say -infinity to -2, union -2 to 6, union 6 to infinity. Right? Definitely easier to do that, but I'm okay with either answer. It's important to find the domain of these because we're going to be graphing these. And so if you're graphing it, you need to know where the domain is skipping. What's wrong? Just writing nothing down.
I wrote something down.
We talked about those 10 basic functions that you should know. One of them was the reciprocal function is what they called it. I called it a rational function. But 1 over x, you should know the basic shape of 1 over x. Remember the basic shape of 1 over x? If you plugged in 0 here, it's not going to work. But if you plugged in 1, you get 1. If you plug in 2, you get 1/2, and then 1/3, and then 1/4, and then 1/5. And plug in 100, you get 1/100th, right? It just keeps going down closer and closer to that x-axis, but not ever getting there. And if you plugged in fractions here, right, 1 over a fraction flips it over. So if you plugged in 1/2, you actually get 2. If you plug in 1/3, you get 3. If you plug in 1 over 100, you get 100, which means this side just keeps going up. And it's an odd function, which means it just flips over down here, right? And this side goes down like this and up like this. Kind of a terrible graph, but basic shape of a rational function. We can do transformations with this. We can do stretches. We can do shrinks. We can also throw in some crazier things, like when you throw an x on top, that kind of changes things a little bit. But there is both a vertical and a horizontal asymptote on this because your domain excludes 0 and your range excludes 0. So it never touches the x or the y-axis. There's no number you can plug in there that would make x or y equal 0. And so remember that your asymptotes go hand in hand with what your domain and range are, right? Your vertical asymptote is where the domain skips, right? So the vertical asymptote is the line x equals 0. And your horizontal asymptote is where the range skips, which would be the line y equals 0. So I just want you to kind of see that connection between domain and range and vertical and horizontal asymptotes. So way back on that chapter P quiz, I gave you a question and I asked you to list all the asymptotes. I didn't make you graph on the chapter P quiz, but you will have to graph on this test. But I'm going to give you that same slide. Good news is I printed it out this time, so you don't have to write it all down, with the rules for vertical and horizontal asymptotes. And again, we always kind of freak out when we see stuff like this, but this is just how we write polynomials. Right? We start with a leading coefficient, with a power, and the power usually goes down by 1 until we get to a constant. And then we're just doing the same thing at the bottom, only a different polynomial. So they use a and b. They use n and m for the degree. And the reason I write it like this is because my rules go back and refer to the degree of the numerator and the degree of the denominator. If you feel like when you go back and look at this, it's not going to make sense to you, we might want to change and write degree of numerator, degree of denominator. So the vertical asymptotes are just where the denominator equals 0. So set denom equal to 0. That's what that says there. A lot of times you can just look at it like we did in the first problems, because if you know the domain, then you know the vertical asymptotes. But for horizontal asymptotes, you have to just memorize these rules. Like there's no computing it. You just have to know that it's the degree of the numerator compared to the degree of the denominator. So if the numerator is less than the denominator, like 1 over x, like we just had, then it will always be the line y equals 0. So if you think you're not going to remember what n less than m means, you need to say if degree of numerator is less than degree of denominator. That's why we write this, so that we can shorthand the rules here. If the numerator and the denominator have the same degree, like they're both x squared, then remember the horizontal asymptote is whatever the leading coefficients are. So again, this refers back to up here. If these are the same number, then your horizontal asymptote is the line, whatever that is. It could be 1/2, it could be 7, it could be any number if the degree of the numerator is the same as the degree of the denominator. And then if the numerator is bigger than the denominator, there is no horizontal asymptote. And in chapter P, we just left it with that. What we're going to talk about today is if there's not a horizontal asymptote, it means there's a slant asymptote. And we'll do an example in a minute on how to find that. I will tell you that on your test, I will not give you a problem that you have to graph a slant asymptote, just because it gets a little crazy sometimes. But you will have to find a slant asymptote. But we're going to graph that today, just to kind of see a little bit. Yes, vague memories of this? Pretty sure if you go back to your chapter P notes, like it's word for word. Like I think I just copy and pasted the slide from my chapter P notes. Oh my gosh. So big because I was going to leave the over here. Page. There are questions on your homework today that say find all asymptotes. So you do not have to label which ones are vertical and which ones are horizontal because they're equations. Vertical asymptotes are always x equal, horizontal asymptotes are always y equals, so you don't have to say, these are my vertical asymptotes, these are my horizontal asymptotes. But you do need to find them all. So if I want to find the asymptotes of this, I usually start with my vertical ones because I know I'm just going to set the denominator equal to 0, and I'm just going to solve that. Normally, we only have 1 or 2 vertical asymptotes, but there really could be like 3 vertical asymptotes. I would never make you graph one like that, but. And this, we could factor this, or we could just add 9 over, and we get that there are asymptotes at both x equals 3 and x equals negative 3. The vertical asymptotes take a little bit of work. The horizontal asymptote, it's all about these rules over here. The degree of the numerator compared to the degree of the denominator. So which one is this? Is the numerator less than, greater than, or equal to the denominator in this problem? A less than, which means if the numerator is less than the denominator, don't just say 0. You have to say y equals 0. It's a line. That's it. That's your answer. Very nice when you don't have to graph it. You just have to write it out. And there's definitely questions on your test with those directions. Find all asymptotes. What about number 5? Vertical asymptote. What do we do? Set the denominator equal to 0. Subtract 1. Divide by 2. Negative 1/2. Not very fun to graph when the asymptote's a fraction, but we don't graph it. That's good. Horizontal asymptotes. You just have to know. Compare the degree of the numerator with the degree of the denominator. These are the same. Do you agree with that? They both have a power of 1. I switched it up on you just to remind you. The leading coefficient is not necessarily the first number. It's the number in front of the highest exponent. And so the horizontal asymptote is the leading coefficient of the top and the bottom, which would be negative 5/2. Y equals. Questions about that? So let's graph one. I kind of just decided to just graph an ugly one first. If you're going to graph this, people kind of hate graphing these because they're ugly, but I kind of like them way better than polynomial functions, because with polynomial functions, you have to find all the zeros, you have to think about the end behavior, you have to pick points in between. With these graphs, if you can find the asymptotes, we kind of know the shape, and so then we can just pick a couple points and follow the asymptotes. So step 1 on these, I think, is you should find your asymptotes. So horizontal is kind of nice because you don't have to do any work for that. You just have to know the rules. The degree of the numerator is less than the denominator, so what do I know about my horizontal asymptote? It's y equals 0. Right. What do I do to find my vertical asymptotes? Set the denominator equal to 0, which means I might actually have to do a little bit of work on this one. Well, multiplies to give me 6, that subtracts to give me positive 1. Positive 3, negative 2, which means I actually have 2 vertical asymptotes. X equals negative 3, x equals positive 2. Remember, asymptotes are just like imaginary lines on your graph that it gets closer to but never touches. So I like to make them as dotted lines on my graph. So y equals 0 is the x-axis. X equals 2. And x equals negative 3. A couple things I want to remind you of that we talked about in chapter P, but it has been a while. The horizontal asymptote means as the graph gets bigger and bigger and smaller, it gets closer to that line. But remember, sometimes the middle part of the graph can cross the horizontal asymptote. I'm not saying this one does, but sometimes that happens and people kind of get thrown off by that. Kind of this whole talk about limits, that a horizontal asymptote is what's happening as x approaches infinity and a negative infinity. So just know that it can cross the horizontal asymptote. It will never cross the vertical asymptote. Also remember that the outside pieces will always be those shapes like 1 over x. You just have to figure out where they start. So if you just pick a point on either side of the vertical asymptote, we can figure out, is it going to be up here or down here, and we can usually just maybe pick one point. So step 2, pick points on either side of vertical asymptote. So I'm just going to pick 3 for x. And it's kind of a pain when there's lots of x's in the problem, but you can use your calculator, or you can just actually figure it out. If we plug 3 in the top there, we're going to get what? 9 plus 4, which is 13. And if we plug 3 in the bottom, we're going to get 9 plus 3 is 12, and 12 minus 6 is 6. And 13 over 6 is 2 and 1/6. Which you can type on your calculator. I'm okay if you type it on your calculator, but either do the top and the bottom separately or use parentheses. Like, if you don't use parentheses, it's going to give you the wrong answer. If you have issues with this, let me know. But if I put 3 in here, I know that this is going to be at 2 and 1/6. I could be really accurate and maybe pick another point over here to kind of see how fast is it coming down, right? But I know for sure this side has to go up towards this asymptote, and this side has to come down towards that asymptote. So I'm just going to wing it. I do want to see at least 1 point out there. Over here, I also need to figure out, is it going to be up here or down here? So again, I would pick 1 point, which in this case, I would pick -4. And if I pick -4, I get -12 plus 4, which is -8 over, oh my gosh, 16 minus 4. I know, it moved on me, right? 16 minus 4 is 12, and 12 minus 6 is 6. Is that true? So that's just -4/3. -1 and 1/3. Which again, the asymptotes tell me this side's going to go like this, and this side's going to go roughly like that. If there's only one vertical asymptote, like you're done with the problem because you'll have your 2 outside parts, there won't be an inside part. The inside part is usually one of 2 things. Do you remember the 2 things that usually can be? Either be like a cubic kind of shape where it's like S-shaped, or a parabola. This is where you might have to actually pick a few points, and remember it can cross this line, so don't assume that if you get a point down here it has to be a parabola. You actually might have to pick a few points. This is where a calculator is nice instead of me doing all this at once. I'm going to pick 0 first. Because if I pick 0, I'm just going to get 4 over -6, or that's just -2/3. Let's say that's about right there. If I pick 1, I'm going to get 7 over -4. Or that's -1 3/4. Let's say that's about there. Which means maybe we should pick -1 to see what happens. Is it going back down over here, or is it going up here? That kind of would let me know. If I pick -1, I'm going to get 1 over -6. Is that true?
Yes.
Because it'd be 1 minus 1, -6. So that would be -6 like this. Oh my goodness.
That's a cube.
Should we pick another point just to make sure? Has anybody picked -2 yet?
I think everybody is good.
I know, you're all just sitting there like bumps. Bumps on a log, just waiting for me to do all the work.
Yeah, we'll do our work something like that.
Yeah, we'll see. I'll check tomorrow and see. -6 plus 4. -2.
1/2.
4
Minus
minus 2 is 2 minus 6 is -4.
Oh, that one is right.
I don't have a calculator.
Do I?
Don't lie. Someone told you. I think it's the cube. I think it's a safe bet now. Oh, that's kind of a pain sometimes in the middle there. I can tell you 100% there's one on your test like this that has 2 vertical asymptotes. That's worth like 8 points. Really important. I tend to do this without a calculator because it's really easy to type something wrong in your calculator. Remember, if you type negative numbers in and you square it and you don't put parentheses around it, it gives you the wrong answer. So just be careful that you don't rely too much on your calculator if you're typing things in incorrectly. Oh, that's terrible. Okay. This one's much better. Wouldn't it be great if I gave you this one on your test?
Yes.
We should have done this one first.
Roll down and leave that.
It's just some things are tedious to do, and that's one of this is a graph that's very tedious. This one's not very tedious. What is the horizontal asymptote of this graph?
3.
Horizontal.
0.
Wrong.
1.
Y equals 0.
Oh my goodness, are you kidding me?
It would be wrong if you just write 0. I'm marking it wrong.
I'm not gonna yell it out. Real quiet.
Vertical asymptote. What would make this denominator equal 0? 3.
3.
X equals 2. super great. We did the awful one first. People always say I do easy ones first to build you up, and then I knock you down with the terrible one, and I switch it up on you. We did the awful one first, and now I'm like, oh, look how great it can be. If there's only one vertical asymptote, all we have to do is figure out what's happening on either side of this, which means what would be a great point to pick? 2, right on either side of your vertical asymptote. And if you plug 2 in there, what do you get? 2, 1. Which means I don't have to pick any more points on that side because I know this side goes up and this side goes down. What else should I pick? On the other side, 4. If I plug 4 in there, what do I get? Done with that problem. So they're not all terrible. Some are terrible. We can also talk about transformations on this, just to let you know the 3 here, right? It's kind of moved over 3, and the negative, like because it's 3 minus x instead of x minus 3, like it's flipped. Like normally it was like this, and so just kind of thinking about transformations on that one, you could do it. But just know, some of them are like that, and so they're not all terrible, but sometimes they are terrible. Slant asymptotes. We did not talk about slant asymptotes in chapter P. You did talk about slant asymptotes in chapter 9 of algebra 2 last year. But a slant asymptote is when there's no horizontal asymptote, when the numerator is bigger than the denominator degree. And the way you have to find it is to do good old division, which we've been doing a lot of, right? So here we go. Find all asymptotes.
I got one of them.
What do you got? X. Vertical asymptote. Is there a horizontal asymptote on this?
Nope.
No, the numerator is bigger than the denominator, so there is no horizontal asymptote. If there's no horizontal asymptote, that means there's a slant asymptote. I said use long division. That's because you can't always do synthetic division. Synthetic division only works when it's a binomial on the bottom, right? So if this was like x cubed on the top and this was x squared on the bottom, you have to do long division. If you want to do synthetic division on this one, you could, because x minus 1 does work for synthetic division. But I'm just going to do long division, just to remind you, because sometimes you're going to be stuck with long division. Remember to fill your zeros in if you need to, but in this one we don't. And remember, you're trying to say, what do I multiply this by to get this? You just look at this first one and this first one, and it would be 4x. You take that and you multiply it by this whole thing to fill that in. So you would get 4x squared minus 4x. If your exponents don't line up, then you've done something wrong. Great.
Is it wrong? Will it be counted wrong?
I just said that. No. You can do synthetic division on this one because it works for synthetic division. Do I have another one on here? I don't have a good example. Sometimes synthetic division doesn't work because you can only do synthetic division when it's a binomial, right? You see what I'm saying? If it's not a binomial, you're stuck with long division. I'm subtracting, so I like to subtract through, and that would become 2x plus 1. What do I multiply x by to get 2x? That would be a 2. And I get 2x minus 1. Here's what's great. I'm going to actually work this out. I actually get a remainder of 2 here, right? Oh, you always hate when I put my negative through. Because this is really a minus 1, but I subtracted through.
Yeah, I was wrong.
Oh, this should be minus 2. Here's the good thing. The remainder means nothing for the slant asymptote. So who cares if you screw the remainder up? Because it means nothing for the slant asymptote. The slant asymptote is what it is without the remainder. So once you get to the point of knowing all you have left is the remainder, you can stop the problem. Or if you're doing synthetic division, you just disregard the remainder. Your slant asymptote is the equation y equals whatever you get here without the remainder. So y equals 4x plus 2 would be that slant asymptote. So although there is a remainder here, it means nothing in terms of the slant asymptote. You with me on that? So maybe we should write here. Disregard So I think I put a big giant graph on this one, right? Because I wanted to show you what a slant asymptote looks like. The problem is that sometimes you get really big numbers, but you still do the vertical asymptotes the same way. So x equals 1 would still be this line right here. And your slant asymptote of 4x plus 2 is exactly that. It's a slanted line, so that's why they call it slant asymptote. It has a slope and has a y-intercept. So you could graph it and make it dotted, right, at 2, and then you have a slope of 4. So you could go up 4 over 1, up 4 over 1. With me on that? Slanted line. Your graph is still cut into 4 sections, just like with a vertical and a horizontal one, but instead of being like perpendicular, right, it's slanted. So your graph is either going to be in these 2 sections or in these 2 sections. So if you are going to graph this, again, all you have to do is pick a point on either side of your vertical asymptote to see where that starts, and then the asymptote guides your graph. So if my vertical asymptote is at 1, let's pick 0 and see what we get. If I plugged 0 into that function, would I get negative 1?
Yeah, I got it.
0 is my favorite number. So I don't do a lot of work. Which means I can say with pretty good accuracy that my graph is going to follow this asymptote, and it's not going to be a perfect parabola because this one's slanted, so it's going to come out and follow that asymptote. I can even say, I'll pick one more point to kind of see where it starts, but the other half of this graph is going to be up here in this section. If one of my graphs, if this point would have been out here, then the other half would have been over here. So they're still kind of like on opposite parts. So what if we picked 2 here? So do some work now. 4 times 4 is 16, minus 4 plus 1. On the bottom, we just get 1. So 13, which is why it's kind of ugly, because you have to go up here. This would be 10, 11, 12, 13. This side would go up. This side would be slanted. Questions about slant asymptotes? I don't think I'm going to make you graph the next one, but I want you to find the slant asymptote. I think I have the graph on, but I won't make you do it. So find all asymptotes. That's a negative out there, just so you're aware. They confuse you. I put a graph there, but we don't have to graph it, unless you just want to. Because I can tell you all really want to. We kind of put that negative up on the top if we're going to do long division. Or on the bottom. Either way would work. We should get the same answer. But that negative does belong somewhere. If you put it on the bottom, you can't do synthetic division, right? Because it changes everything. So you're just waiting for me to do it. X equals negative 5 is an asymptote. Get that part done. Again, not a horizontal asymptote because the numerator is bigger than the denominator. So 2 options here. One option, you can put the negative on the top and make that negative x squared minus 1 over x plus 5. And if you did that, you could do synthetic division. Fill your 0 in up here because it skips x, because that is in the right thing. If you do it the other way, if you leave the top as x squared plus 1, but you make the bottom negative x minus 5, that does not fit the formula for synthetic division, x minus r, because of that negative there. So you'd have to do long division. But either way you do it, you should get the same answer for your slant asymptote when you do long division or synthetic division. Do you want me to do both ways or just go one way? Have anybody started this yet?
Well, yeah, it's
I did long on the last one, so I can do synthetic on this one. If you do it this way, you have to fill that 0 in though, right? It would be plus 0x minus 1.
For a second, I thought
Right, the remainder means nothing for this, but if you're doing synthetic division, remember that you take the opposite sign there, so you're actually taking negative 5. 5, 5, negative 25. But remember, this means nothing, so like I don't even write that. And that would just be y equals negative x plus 5. Be your answer. And again, I won't actually graph the whole thing here, but just to kind of show you what the slant part looks like, if you graphed the vertical asymptote, it would look like this. And then the slant asymptote would have a y-intercept of 5 and a slope of negative 1. So it would kind of look like this. Which means, again, the annoying part about these, which is why I don't make you graph one of these on a test, is there's usually pretty big numbers because it's either going to be on these two halves or on these two halves. And so it just tends to go off the graph a lot. But that's the idea behind a slant asymptote. And you will have to, on your test, there will be questions from this section that say find all asymptotes, and there will be a question that you have to graph, and I'll even tell you it has 2 vertical asymptotes in it. Kind of a review from chapter P with a little extra. Really only 10 problems. They're all individual problems. There's not any like through this. 24, 27, 39, and 43, I do want you to graph those. One and 2 is just domain. They talk about limits. Just disregard any directions about limits because I kind of just wait till calculus to teach about limits. 20 and 21 are just asymptotes. Again, disregard about limits. And then the directions do say it's a graph on 24, 27, 39, and 43. Yeah, so 39 and 43 are not as nice. Oh, maybe they're just all not so nice, but 4 graphs. 63 is true false. That's a good one, right? 67 is multiple choice. So 4 graphs. Find your asymptotes, pick points. If you want graph paper, I can give it to you. If you want to just draw your own graphs, I'm okay with that too.